Hello everyone, welcome to chemistry. Remember, we are doing stoichiometry, and according to the new syllabus, this topic has been divided into two parts known as chemical reactions 1 and chemical reactions 2. So we are doing chemical reactions 1 and we are on third lesson. So this is how we are moving in this topic of stoichiometry. And in lesson 1, we discussed how to balance these chemical equations. And in lesson 2, we started the second part, which is relative formula mass. And in this lesson, we are going to finish the relative formula mass, and we are also going to start more concept. So after that, we'll be moving to percent water in molecular and hydrated ionic compounds up to the percent yield. So let us discuss how to write chemical formula. The most important thing to write a correct formula of a compound, you need to remember these three things. So in order for you to write correct formula of a compound, you need to remember these things. The first one, write correct symbol of element or radical. You need to write a correct symbol, the chemical symbol of element or radical. Second one, you need to write correct valency of element or radical. You need to write correct valency of element or radical. I think we discussed more about valency in our previous lesson. So here you need to write a correct valency of element or radical. The last one, when you're writing a formula, an atom from the lower group is written first except for organic compounds and other few exceptions. For example, we know hydrogen react with oxygen, it gives us water. So water, its chemical formula is H2O. So we start with H just because hydrogen is in group 1, which is lower than the oxygen, which is in group 6. So when you're writing the formula, you need to start with an element from the lower group. So there are few exceptions. For example, for organic compounds, e.g. Methane. You see, methane, you react carbon plus hydrogen, so it gives you, for example, methane, which is CH4. So in this case, CH4, you see carbon is in group number 4, hydrogen is in group number 1. So you have seen that carbon, we have started with carbon, then hydrogen. So for organic compounds, that one doesn't apply. But for most of the compounds, their chemical formula, you need to start with an element from the lower group. So let us look at steps in writing correct chemical formula. So there are several ways in which can guide us to write correct chemical formula. So step number 1, write the correct symbols of elements or radicals. Write correct symbols of elements or radicals. For example, magnesium reacting with chlorine. So you want to find the correct chemical formula. So you need to write correct chemical symbol. For example, for magnesium is Mg, and for chlorine is Cl. Step number 2, write the values of given elements as powers on each element. So for example, our correct symbols, we have magnesium and chlorine. So you need to write the values of each element as powers. For example, magnesium has a value of 2 and chlorine has a value of 1. So you write on top of those chemical symbols. Now step number 3, you need to swap values and write them as subscripts. So in step 2, you wrote them as powers. Now they need to be swapped and be written as subscripts. So for example, magnesium magnesium has values of 2 and chlorine has values of 1, so you need to swap, you need to switch. So for example, chlorine with 1 valence, that 1 valence will switch to magnesium, but it will be like a base or a subscript. Likewise, for magnesium, which has 2 as valence, also switch, also swap to chlorine um, as a subscript. So this is what happens. 1 has gone to magnesium as a subscript, and 2 also go to chlorine as subscript. Step number 4, you need to write the symbols close to each other with values written as a subscript. So on this step again, you need to divide those subscripts with the lowest number. For example, we have magnesium with 2 and chlorine with 1. So after dividing 1 as the lowest term in chlorine and magnesium, we found that it's magnesium 2 chloride. So it's magnesium chloride. That is the correct chemical formula when magnesium reacts with chlorine. Now, let us start looking at relative formula mass, also known as RFM, or relative molecular mass, also known as RMM. So let us start defining what RFM is. So RFM is the mass of a molecule relative to mass of carbon 12. It's the mass of the molecule relative to mass of carbon 12. So that's the definition of RFM. Now let us go to how to calculate RFM. So RFM uses relative atomic mass. So RAM, also known as RAM. So if you want to calculate RFM, you use relative atomic mass. For relative atomic mass has no units because it is the average of mass of one atom of element compared to mass of one atom of carbon number 12. So that gives a ratio. So the RFM has no units. So let us go to RFM. As I've already said that in order to calculate relative formula mass, you need to use relative atomic mass. So relative formula mass is the sum total of relative atomic masses of all the atoms in the compound. So you can also define relative formula mass as the sum total of relative atomic masses, known as RAM. So when you add all relative atomic masses, that's when you find RFM. So as we have already said that in order to find RFM, or relative formula mass, we need to use relative atomic masses. So these relative atomic masses, when they are added, they give us relative formula mass. So let us see some of relative atomic masses of some elements. So we have hydrogen with 1 as relative atomic mass, and sulfur with 32, oxygen with 16. So these can be found on the periodic table. They are also known as atomic mass. So these relative atomic masses are usually rounded off to whole numbers. So most of them, they have decimal places. So they are usually rounded off to whole numbers. Now let us see how to calculate relative formula mass of compound. So as we have already said that in order to calculate relative formula mass, we need to use relative atomic masses. So step number 1, you need to write correct formula of a compound. For example, here we have calcium chloride. So for calcium chloride, that one is a correct chemical formula. Thereafter, we need to identify relative atomic masses of each atom or ion in the molecule. For example, we have calcium chloride, so we need to identify the atomic masses of each atom. Now for calcium we have 40, and for chlorine is 35.5. The last step, we need to add relative atomic masses of all atoms present in the molecule. So we need to see calcium. We have one atom of calcium. So for calcium is 40. Then we add chlorine. We have 2 atoms of chlorine. So it's 2 times 35.5. So by adding that, by summing up, we usually find relative formula mass. Now let us do this example together. So question number 1 is saying calculate the relative molecular mass of ammonium sulfate. So the first step, we need to write correct chemical formula for ammonium sulfate. So chemical formula for ammonium sulfate is that one. So now we have written the correct chemical formula. Now we need to identify relative atomic masses. So relative atomic masses of nitrogen is 14, hydrogen is 1, sulfur is 32, oxygen is 16. Then after that, we need to add all those atoms based on relative atomic masses. So for example, we have 2 nitrogen atoms, and each nitrogen has a relative atomic mass of 14. So we have 1 nitrogen in the bracket, and that 1 nitrogen is multiplied by a subscript which is outside that bracket, making to 2 nitrogen atoms. That's why we have written 14 times 2. For hydrogen, we have 4 atoms there, and we also have 2 outside there. So 2 times 4, and the times relative atomic mass of hydrogen, which is 1, and then we have 1 atom of sulfur, and we also have 4 atoms of oxygen. So after doing some calculations, for nitrogen we have 28, which is relative atomic mass, and we also have 8 for hydrogen, 32 for sulfur, and 64. When we do some addition, we found that relative molecular mass of ammonium sulfate is 132. Now let us start looking at this interesting part known as mole concept. So let us first define what is a mole. So a mole refers to a quantity of substance that contains 6.023 by 10 to the power 23 particles. So any substance that contains 6.023 by 10 to the power 23 particles is known as a mole. So this number is called as Avogadro's number or Avogadro constant. So the 6.023 by 10 to the power 23 particles, that number is known as Avogadro's number or Avogadro's constant. So 1 mole of anything contains 6.023 times 10 to the power 23 entities. So when we say this is 1 mole, we mean that that substance contains 6.022 times 10 to the power 3 entities. So entities, what it means is it can be atom, it can be molecule, it can be compound. So anything contains 6.022 times 10 to the power 23 entities. So it is necessary to state type of particles being referred to, for example ions, atoms, molecules, or electrons. So in the definition we just said quantities of substance that contains 6.023 times 10 to the power 23 particles. So we need to specify. So when we say particles, so is it ions, is it atoms, is it molecules, or electrons? So we need to specify that. So for example, when we say 1 mole of hydrogen, it means in that 1 mole there are about 6.022 times 10 to the power 23 atoms of hydrogen, because now the 1 mole is the 1 mole of hydrogen. So 6.022 times 10 to the power 23 atoms are the atoms of hydrogen. Likewise for methane, that's that we say 1 mole of 1 mole methane, it means 6.022 times 10 to the power 23 molecules of methane. Likewise, when we say 1 mole of calcium chloride, we mean that we have 6.022 times 10 to the power to the 3 formula units of calcium chloride. So you need to specify what particles are they. Are they hydrogen? Are they atoms of hydrogen, or molecules of hydrogen, or molecules of methane? So you need to specify the quantities or the entities you are referring to. Now let us see the more equations, or the equations which we are going to use to calculate moles in this mole concept. So in general, number of moles is equal to mass of substance divided by mass of 1 mole, or RFM. So this is the general formula for number of moles: mass of a substance divided by RFM. And the second formula is the number of moles of gas. Now, so in order to calculate number of moles of gas, you say volume of gas in a decimeter cubed at room temperature divided by 24, or volume of gas in liters at room temperature and pressure divided by 24. So in order to calculate moles of solutes, can be calculated by concentration multiplied by volume. So these are the formula which we are going to use in the mole concept. So you need to remember all these formula. So this marks the end of today's lesson. In the next class, we are going to use those formula which were discussed in the previous slide on how to calculate moles of substances in simple ways. So please don't miss the next class, because we are going to do some calculations on how to calculate moles of substances in simple ways.